All right, had a few questions on some of the homework from the book, so I'm going to go over those as well. We're going to go over number 30, 32, 38, and 40. I'm not going to go all the way through, but I'm going to give you help on how you can get some of those started if you do have questions. If you don't want to watch the entire video, down below in the description, you can just click on the time link and jump right to whatever question that you want to take a look at. So the one we're going to start with here is number 30. That's that kind of parallelogram shape. So I'm just going to kind of read out of the book here. You guys got your books or pictures there with you, so I'm not going to go through all of it. But we have that the longer side of a parallelogram is 6 meters, and that kind of bottom corner, B to A to D, 56, alpha is 35. So that means that line kind of splits that in half. So we should have a 35-degree angle and I suppose a 21-degree angle opposing that. And some of the stuff that you maybe remember about parallelograms from geometry is that opposite angles actually have to be equal in a parallelogram. So we know that this kind of upper angle here is 35 degrees, right? That has to be 35, which means the lower angle has to be 21 degrees in order for that to add up to be 56. And so those two angles, parallel lines, you guys answered that before, kind of the angle of elevation, angle of depression, it has to be the same angles, but sort of in their counterparts up top here. So same type of thing, but up there. And then that allows you to find this last side there, 180 minus 56. In that case, you can find that upper angle. In fact, though, well, actually, you do need that. So we can get that angle there. Also, we know that the longer side, again, 35 is a bigger angle, so the side across from it has to be a little bigger than the side across from 21. So I know, what did it say here, that is 6.0 meters, so I'm just going to put a 6 up top. Same thing down below, parallel sides of parallelograms are actually equal, but it doesn't really matter. So now the thing here is, all I need is that top triangle right here. That's the only triangle that we need on that case in order to do that. Because now we have 6 across from 35. We have that one. We can figure out what this angle is. That's across from the diagonal, and we can set up the law of sines. 6 over sine 35, something over sine of whatever you figure out this angle to be. So that's number 30. That's at least how we can kind of set that up to start. Let's see. Next one. Number 32, and here we want to find the height of a kite, and it's a little bit deceiving because it shows the line of that kite, which we don't actually need the line of that kite. It's showing two different people have some angles of elevation going up to the kite. So what I would think through first, if I want to know the height of that kite, maybe I'll draw my little picture here. There's my kite sitting there, and if I want to know the height, that means from the kite straight down to the ground, right? That's what I want to know. I want to know this height, which I'm just going to put an H right there. I'm going to start by drawing that in. Well, I don't quite know what that is, but hey, you know what? From this spot down to that first dude on the ground, that's a 78-degree angle of elevation. So I pretty much have almost a full right triangle. If I knew one of these sides, we could figure out H by doing, setting up a little bit maybe of like tangent to the bottom side or sine to get it to the hypotenuse, and then just solving that. So if I can figure out one of these two ones, then we're good to go. It seems like I should be able to, because we're told that 30 feet back, there's another person staring up at this. Must be a really nice looking kite up there, because we got one person, flying it, and then two other people kind of staring at it. But this is at a 62-degree angle right there, right? So we know that they're 30 feet apart, practicing good social distancing right there. And so then we can kind of figure this out. We know that this is 78. And so we can go inside here, do 180 minus that. We can find this inner angle, right? So we should be able to figure out this inner angle here, right? Which I'm just going to say alpha for inner angle. Just track that away. And then we would be able to figure out this top side as well, because we'd have two angles. We can figure out this last angle in here. And so we have that dot, which means it's going to be a couple of steps to get there. But we have this triangle right here on the left. We have a bottom side across from an angle that we can figure out. So in other words, we have 30 over sine of whatever that dot is, right? We can figure that one out. That should be equal to this side here, which is our hypotenuse. I'm going to call that x for right now, right? This x side is across from 62 degrees in our very left triangle. So x over sine of 62, we can do that one. So we can solve this little thing here just using the law of sines, and we'll have x, which will be a hypotenuse. And then we could sort of take a look at this right triangle on the right. We have 78, got an opposite side, we got the hypotenuse. We could set up a short little trig function there and just solve that out, and that should be able to find what the height of that kite, sorry, I'm thinking of triangles, I almost call it a triangle, but what the height of that kite is on that one. Okay. So next one there is number 38, a little more difficult because they don't give you a picture on this. You kind of have to follow the words that are on there in order to get that picture. So to go with here, I got to give that one a quick look over. Okay, he's in a ship traveling due east. So again, if I went to here, I might just draw a little map up on the top to help me out. North, south, and then I do by making the word we going across. That's how I kind of remember that. But he's going east at 8, sights a lighthouse with a particular bearing, and then 1 hour later, re-looks at that same same lighthouse, right? So basically, he's in a ship and he's heading east, right? And that's what he's doing. He's going 8 miles per hour. So 1 hour later, he has traveled 8 miles to a new spot. That's essentially what he's done. And so now he's looking at this White House. So when he starts, he looks south 55 degrees towards the east, right? That's that's how that bearing kind of looks. So he's looking south and then 55 degrees towards the east and spots a lighthouse, right? So that means in here, there's a 55-degree angle right there, right? Look south and then 55 degrees to the east. That's how you read that. On the next one, at this point, it says he looks south, but then 25 degrees to the west. So he looked at the same lighthouse and looked 25 degrees to the west that way. And now here, what we would be able to do, I mean, this is east, this is south, so we should be able to figure out what this inner angle is, that first dot there. We should also be able to figure out this angle, maybe I'll call that alpha. And once we have these two, subtract them from 180, that gives us this bottom angle right here. And we can find the closest that the ship came to the lighthouse. You can use this, maybe use law of sines to find one of these two sides. It doesn't actually really matter which one you want to find on there. In fact, here, you know what? It wouldn't really matter on that one. Let's take a look. I got to try this just a little bit more, but at least that gives us a little bit pieces on there to find there. And then if we want the closest, we could draw right in here. That's going to be whenever it's perpendicular in there. So I'll let you guys kind of think about how might you go about finding that, because if we know this, we have an angle here, and we know we can figure out this side and then figure out this one again. Use kind of like the kite problem, law of sines to find out one of these two, and then use that side as a hypotenuse of the right triangle to figure out the rest. Maybe set up sines or cosines to figure that stuff out. So you can figure out this height, that would be the closest that they ever came to that lighthouse. So that's number 38, at least some pieces to help you figure out on there. And then the last one that I'm going to take a look at here is number 40. That's that solar panel on top of the house. They give you a little bit of a picture, but they don't put all of the information into that picture. Some of that is left for you to kind of think about how that works. But they do label the tall feet on there. They said the roof has a pitch of 15 degrees, and they mark that for you. And the one that they don't put on there is that the brace of the panel has to be installed at a 40-degree angle with the horizontal. That just means, if you have your horizontal, it's tilted at 40 degrees compared to the horizontal. So if I were to just draw that solar panel in, what I would do is here's the 12-foot solar panel right there. There's the face of that solar panel, and the sun's hitting that. And then it has to be at a 40-degree angle to the horizontal in that case, right? 40 degrees to the horizontal, and then there is an angle right there. Now, there is the roof underneath this, right? And then here's the horizontal. So there's kind of three things going on. it's 40 degrees from the horizontal all the way up to the base of this thing. So that's 40 degrees. 15 degrees are taken up by the roof, right? Meaning that you have 25 degrees left over right here. Or actually, sorry, the panel goes all the way up to that one. Whoopsie daisy, not 25 degrees right there, right? Sorry, this one here, 15 degrees that it's on the roof. Sorry about that. 40 degrees all the way up. So actually this is a, oh boy, can't even write anymore, getting too late in the day. 25 degrees right there. So that is a total of 40 degrees up to where that panel is. And then up here, we just need to know this vertical distance on that one. So it seems like we might not be able to figure that out because we need another angle in here in order to solve that, right? But we do know it's to the horizontal. So this wants to be completely vertical. We can actually draw that straight down and make that a right angle. So there's a little right triangle on the bottom we could draw in of that panel. So since this is 15 degrees, we can figure out what this spot is. I'm going to put a little dot there, which then means this is a straight line. So we should be able to figure out the top of that dot, maybe call this alpha or something like that. And so we can figure out all those pieces. So we have something across from our vertical component. Maybe I will call that V for vertical, right? And we have an angle across from 12. And we can set up the law of sines to find that vertical component as well. So hopefully some of those pieces help out from that book. If you do have a few more questions, send me an email and I'll either make some more videos or maybe we can get that across as well. So good luck.